Hello students, I am Rajiv Jha. From this video you learn about the need of large size of alternator and I try to explain all possible aspect of understanding. So let's begin. Okay, the question is why does size of alternator larger than other rotating machine? This is the question many time asked in PSU or interview in different MTech and PhD interview actually. So this is the most important question I have seen. So the size of electrical rotating machine, as we know, if the size of any electrical rotating machine is increases, then the cost is also increases. So size is directly proportional to the cost of machine. So instead of this drawback, alternator has the largest one. The largest one. Alternator has the largest one with compared to induction machine and DC machine for the same power rating. Here you see, for the same power rating the alternator has contained the larger size as compared to the DC machine, and induction machine has the least size because of the um, as we know the alternator wants more stability as compared to the induction machine, because induction machine is the industrial used for generally used for the industrial purpose. So it's only it's only take more it's only concentrate on their power factor. But in alternator power factor is also important, but the most important is the stability because of it is a directly connected to the main grid. So that is the another topic we will discuss later. The main reason of size of alternator is larger because of stability, voltage regulation. That means if the size is increases, the stability is increases, voltage regulation is decreases, more locking, more voltage controlling. So the wide range of voltage controlling is available if the increase of the size or size is increases. How it is possible, we will see the next our next. So here in this slide we see the size of alternator is basically depends on the air gap length. So air gap length, we know the length air gap between of there is a air gap between of stator and magnetic field. So the size of alternator is increased, then air gap will be should be increased. So the air gap is increased, then it is directly proportional to the reluctance. So the reluctance is also increased. So reluctance is inversely proportional to the armature flux. As we know, there is a very basic formula actually. We know that formula phi equal to mmf upon reluctance. So we will see it next slide also. So okay, here we see this is the flux mmf upon reluctance. So the armature flux is directly proportional to the armature reaction. So the here we see reluctance is increased, so flux is decreased, so this flux is called the armature flux. Armature flux is directly proportional to the armature reaction. That means so in previous slide we talk about the formula. So this is the formula, and here we know the armature flux is directly proportional to the armature reaction, because armature reaction as definition we know the effect of armature flux on main field flux. So if the armature flux is decreases, then effect is also decreases. That means the armature reaction is decreases. So if we say armature reaction is directly proportional to the armature reactance, okay, armature reaction is directly proportional to the XAR. Sorry, armature reaction is directly proportional to the XAR. So armature is, that is called the armature reaction reactance. So if armature reaction is decreases, that means XAR is also decreases. So we will see in next slide. Okay, here you see ZS equal to, that is the you see the synchronous impedance is equal to the armature resistance. Sorry, armature resistance and plus armature armature resistance, armature reaction reactance, leakage reactance. So this is the combination of synchronous. From this combination we will make a synchronous impedance. This one is called the synchronous impedance. And XAR and XL, the leakage reactance and armature reactance both are combined is called the synchronous reactance. Okay, so here we see, so the contribution of armature resistance is very less, is the least one actually. The contribution is 0.01 per unit. And for leakage reactance, the contribution is, its value is 0.18 per unit. That means from this, so because of this its low contribution, we can also neglect this. Okay, so we can say approximately equal to JXAR, or it is also called the JXS, synchronous reactance. So here we see, we can say, we know that terms like synchronous, this formula, from this formula we see this is called the, this term is called the synchronous power coefficient or stability factor, that is come from the power equation. We know the power equation P equal to EV by XS sine del. Okay, this one for the cylindrical type of synchronous generator. So stability factor proportional, so here the stability factor comes from the power equation when taken differentiation with respect to load angle. So stability factor, we say stability factor depend on the proportional to the load angle, sorry, synchronous reactance and excitation. So these so synchronous or stability factor is depends on these three variables. Okay, so we can say when synchronous reactance is decreases, as we know the earlier, when the air gap is increases, the synchronous reactance will decrease. So synchronous power coefficient is increases. We know the synchronous power coefficient is directly proportional to the stability. Okay, so if the synchronous power coefficient is increases, then stability is also increases. So in our next slide we will plot a plot a graph between power and load angle. We will see, because from this, okay, this one is graph. Okay, as I told you, here we see when synchronous power coefficient gets positive, this is called the graph actually, gets positive, then stability across, otherwise it will be unstable. That means if the, this is positive, then the system is stable, otherwise system is unstable. So at 90 degree, in cylindrical type synchronous generator, at 90 degree, this is the critical point where the unstable is going to start. Okay, for salient pole type synchronizing power coefficient crosses load angle axis in between of 70 to 80 degree. So this is the general, you can say, I just explained whether it is how it is synchronous power coefficient is directly proportional to the stability or not. So from this graph you can relate it, correlate it. Okay, so we are going to the next slide. So from this you can see size of alternator. When the size of alternator is increases, air gap length is increases, so armature flux is decreases and armature reaction is decreases. Armature reaction reactance is also decreases. So synchronous power coefficient is also decreases, sorry, increases. So stability is increases. So here we see the air gap, the size of alternator is increases, so the stability is increases. From this way you can also correlate this. Okay, so for the next slide we will see. Okay, now we talk about Second, benefits of large alternator. As we know, as we assumed from in the previous slide, ZS equal to approximately equal to synchronous reactance approximately equal to XCR. So because of high contribution like 0.81, so we actually say this. So if we connect from previous statement that if the size is increases then XCR is decreases, so here ZS is decreases, that means V is decrease, V is increases, sorry, V is increases, sorry, V is increases here. Okay, yeah, V is increases, so V is increases, that the regulation is decreases. So because voltage regulation is inversely proportional to the terminal voltage, so we want 5% of voltage regulation for better stability in an alternator. So this can be achieved through this, uh, if we increase the size of alternator. Okay, so from this it will be, so we will go for the next slide. Okay, next slide is more scope of voltage control or wide range of voltage control. So whether we relate with how can we relate with this, with it with size. Okay, so if the size is increased, the air gap is increases, so we put large amount of field current. Okay, that means field current, we can put large amount of field current. So because of large air gap, there is a saturation actually, uh, large air gap, so the saturation is not happening so earlier. That means in this case we will get almost a straight line of pH curve. Okay, so we can say wide range of voltage control possible in case of the, when we increase the size of alternator. So increase the size of alternator, that means air gap length is increases, so field current is increases, or we can increase the field current. So we are not bothering about the saturation. So we can say the pH curve is almost straight line, so we can say the wide range of voltage control is possible. Okay, the last one. So at the last, large interconnecting large interlocking because of large air gap. So this one is because of large air gap, there is a large interlocking system. Interlocking means it is interlocking between of magnetic field, stator magnetic field and rotor magnetic field. So chance of instability due to sudden change in load. Okay, sudden change in load, chance of instability will be reduced. So this is the main benefits actually. So in conclusion, we see stability is increased here with size, and voltage regulation is decreases. Voltage regulation is decreases, and we want to achieve it 5% with large slice of alternator. So and the SCR, short circuit ratio, directly proportional to the air gap length. So the SCR is more due to the direct proportional to the air gap length. And last one is armature reaction, that the effect of armature reaction is low, that mean efficiency is increases because of effect of cross and demagnetizing is also decreases, that means the losses is decreases, so the efficiency is increases. Okay, the next one is, okay, thank you. So thank you for being with this video. Hope you will like this explanation. Thank you.